Hi everyone and welcome to this tutorial session. In today's tutorial we want to solve some two exponential equations. Very peculiar exponential equations. The first one is 3 to the power x plus 2 plus 3 to the power x plus 5 is equal to 28. And then question B, we'll solve for x, the exponential equation x to the power x is equal to 5 to the power 125 plus 2x. All right, without any much ado, let's start. Now, the first equation is 3 to the power x plus 2 plus 3 to the power x plus 5 is equal to 28. Okay, to solve for x. Okay, looking at it carefully, we see here 3 to the power x plus 2. We can actually bring in 3 to the power x plus 2 in this other exponential equation. And so this can be written as 3 to the power x plus 2 plus 3 to the power x plus 2 plus 3. Remember, 2 plus 3 is 5. Okay, we write it as such so as to be able to get the factor 3 to the power x plus 2 common in these two terms. Okay, so if we follow the laws of indices, this will be written as 3 to the power x plus 2 plus 3 to the power x plus 2, all of that multiplied to 3 to the power 3. Okay, we'll apply the laws of indices. This gives us, if we look at it now, we see that 3 to the power x plus 2 is a common factor. So we go ahead and factorize 3 to the power x plus 2. We have 3 to the power x plus 2 into, when we take it away from here, we have 1 there. And then when we take out 3 to the power x plus 2 from here, we're left with 3 to the power 3 is equal to 28. 3 to the power 3 is 27. This gives us 3 to the power x plus 2 into 21 plus 27 is 28. Is equal to 28. So we see 28 is found on both sides of the equation. So we can take out 28 by dividing both sides. If we divide both sides by 28, this 28 cancels, this one cancels there. So we end up with 3 to the power x plus 2 is equal to 1. Okay, so here we see 3 to the power x plus 2, 1. This 1 can be written in index form with the base 3. We just write 1 as 3 to the power 0. Remember, any number raised to the power 0 is 1. Why are we writing like that? So as to have the same base on both sides of the equation. Now, equality means for equality to be valid for any two index expression, the bases must be equal and the powers are equal. Now the bases are equal, so we can just go ahead and equate the powers. From here, we can solve for x by taking the positive 2 from the left-hand side to the left-hand side. And so we obtain the value of x as x equals negative 2. All right. We can always go ahead to check to be sure that what we have done is correct. So we simply put x equals negative 2 on the left-hand side expression to see if we are going to obtain 28. So wherever we find x on the left-hand side, we put negative 2. Let us see what we obtain. Negative 2. Okay. Negative 2 plus 2 is 0. Negative 2 plus 5 is 3. Now, what do we obtain? 3 to the power 0 is 1. 3 to the power 3 is 27. And this gives us 28. So, the value of the left-hand side when x is negative 2 is 28. And that ties with the value on the right-hand side, confirming that the solution x equals negative 2 is correct. Now let's take a second exponential equation. Our second exponential equation says we should solve for x, the equation x to the power x is equal to 5 to the power 125 plus 2x. This exponential equation could look very intimidating at first sight, but all we need to do is to just keep a cool head and we follow the laws of indices carefully. Let's start by handling the right hand side. Whenever we have powers and there's addition, it simply means that this index expression is actually multiplied to this one. The basis must be equal so as to add the powers. If the powers are added, then that's what we get. Okay, from the law a to the m plus n, that should be a to the m a to the n. Okay, when the bases are equal, we add the powers. So from this law, that's what we get there. Now this therefore means, again, if we have the index expression a to the m to the n, it is a to the m n. So we want to handle this. So we're having 5 to the 125 into 5 squared x. Okay, this expression can be written as such, following this law. But what is 5 squared? Is 25. So have 5 to the 125 into 25 to the power x. So we're having x to the power x equals this. Now, if we divide both sides by 25 to the power x, let us see what we get. X to the x all over 25 to the x. 5 to the 125, 25 to the x divided by 25 to the x. So I divided both sides by 25 to the power x. 25 to the power x cancels out there. And on the left hand side, we have x to the x, 25 to the x. Since the powers are equal, we can just go ahead and write this as x all over 25. All right, and then we'll write the power just once. They carry the same power x. So that is equal to 5 to the power 125. Now, from here, if we take power 1 all over 25 for both sides, okay, let's take power, raise both sides to power 1 all over 25. Let's see what we get. X all over 25 to the power x, now raised to the power 1 all over 25. 5 to the power 125 raised to the power 1 all over 25. We have raised both sides to the power 125. We have raised both sides to the power 1 all over 25, sorry. Now, if we look at this carefully, this becomes x all over 25 raised to the power, we take this power, multiply to that power, we obtain x all over 25 is equal to 5 raised to the power 125 divided by 25 is simply 5. Okay, 25 here, 1, 25 there, 5. So it becomes 5 to the power 5. Now look at what we obtain. We obtain 1 all over 25 raised to the power 1 all over 25 is equal to 5 raised to the power 5. There is a match that we obtain here. We see that the base here is the same power, the base here the same power. So by comparison, we can just go ahead and equate either the bases or the powers. And so we obtain x all over 25 is equal to 5. Now from here, if we cross multiply, we're going to have x is equal to 5 multiplied to 25, which is 125. Okay, so let us also check this solution to see if our solution is correct. Let's check. Checking, it means we're going to put x equals 125 on the left hand side and see if we obtain the same result on the right hand side. All right, so we have on the left hand side we have x raised to the power x, so 125 raised to the power 125. Do we have the same thing when we put x equals 125 on the right hand side? We have 5 to the 125 plus 2 multiplied to 125. This gives us 5 to the 125 plus uh, okay, so uh, if we look here, we will see 125 to 125. There's one of it here, and then you have two of it there. So this is like 3 times 125. There is one here, there are two of them here. So 1 plus 2 is 3. 5 raised to the power 3 into 125. Okay? But 5 raised to the power, this is the same as 5 raised to the power 3, all raised to the power 125. So we obtain 5 raised to the power 3 is 125 raised to the power 125. So we obtain this equality where the left hand side equals the right hand side. So our solution x equals 125 is correct.